there, algebras, and welcome to Chapter 4, Lesson 1 notes. Day 1, because there are 2 days of Chapter 4, Lesson 1 notes. Let me just do a quick Chapter 4 overview. We are now starting our chapter on linear functions. So, if we take a peek, we are going to start by talking about slope formula, slope applications in linear functions. That's the thing that makes our lines linear, is that slope, that constant rate of change. We're going to graph some lines, even though we've done it in chapter 3 in the graphing calculator. We're going to use y equals mx plus b form to graph. We're going to model our linear functions, write equations of lines, and have a quick review, and then quiz. Then we're going to talk about something called average rate of change, which is different from constant rate of change being a slope. They're going to be similar and different, so we're going to talk about that. We're going to graph some piecewise functions. We are going to interpret some piecewise functions, and we're going to graph absolute value functions. I know that we graphed absolute value functions pretty extensively at the end of chapter 3, but we're going to apply that a second time. So here we go. Let's get started with day 1 of our slope. So let's remind ourselves that slope is a constant rate of change. It is the vertical change, how much you go up and down, divided by the horizontal change, how much you go left and right. So you'll notice that every time I'm counting my slope, I'm going to count my up and down movement first, then I'm going to count my left and right movement. Okay? Call that rise over run, by the way. The rise is how much up, how much over is the run. We don't just say over, though. I have to say left and right. And the reason is because as we go through, and you'll see why, just saying over isn't descriptive enough as to which direction I'm supposed to go to get my slope correct. So when we start to count it, I will show you why I say up, down, left, right, and don't just say up and over. Okay, so I'm more descriptive than that. Slope is a constant rate of change. If your rate of change is consistent and the same, you get a line. When your rate of change is not constant, you get different types of functions. Okay, so that's why we're so specific about slope as a constant rate of change. The blank, the number, the blank, the line, the higher the number for your slope, the steeper the line. And we're going to look into that a little bit. The slope of a line is a blank. No idea. I lost that one years ago. No clue. But slope is a fraction. Slope is a fraction. It is the change in y divided by the change in x. And as we get into slope formula, you're going to memorize the fact that you've got a difference in your y's divided by a difference in your x's. And once we start to memorize that, we won't need to keep kind of harping back to this. Okay, once we get that kind of memorized and applied. The letter for slope, so every time I'm using slope as a letter, it's an M, and it comes from something French that I don't know. You're going to have to ask Madame Miller, or I don't know who else is up here teaching French anymore. They've changed those people so many times. I think Marsh might teach some French, you know. So here we go. Up on the y-axis is positive. So let me just do a quick sketch. Okay, I'm going to keep these words here, but here is an x and y coordinate plane sketch. Okay, x-axis is your horizontal axis. The y-axis is your vertical axis. Remember, you are basically taking two different number lines and keeping one horizontal, making one vertical, and lining them up at their zeros. That's what you're doing to create this coordinate plane. So they're lined up at their zeros, right? Well, up here for the y's, this is the positive area. So when you're moving up for y, you're moving positively. For x, when you move right, you move positively. When you move down, you're moving negatively. When you move left, you're moving negatively. So each of the different directions has a different sign associated. And that's the reason I'm so specific about up or down or left or right. That's why I'm so specific about that, because each direction comes with a different sign, and the signs in the slope help me determine that correct direction. Okay. So I need to use that appropriately. That comes out throughout using the slope formula, throughout counting the slope of a line, throughout any of this constant rate of change. Those directions drive the sign. Okay. And the sign drives the direction. Okay. It all kind of comes together. So I just want to show you how we count slope, because I count it a certain way so that I get that direction correct. And like I said, I always count a specific direction so that I get my sign on my slope correct. So when I'm looking left to right, the first point I see left to right is where I'm going to start. I always count my up and down first. So I'm going to go up 2, so that's a positive 2 move, and then right 1, that's a positive 1 move. So my slope is, my slope is positive 2 over positive 1. Now, slope can always be written as a fraction. Sometimes slope can be written as a whole number. That's if your top number is divided by a 1 on the bottom, your slope can be written as a whole number. And in this case, my slope is the whole number of 2. And you can see that from the slope formula, the y equals mx plus b form of the line right there. The slope is 2 over 1, or 2. When I go to graph my lines myself in lesson 2, I am going to always write my slope, represent my slope as a fraction. And then that way I'll know how to properly count on my grid. In example 2, the first point I see left to right is right here. So now I'm counting down and right. Down 1, 2, 3, 4, 5, 6. So that's this negative 6 right here. Right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 gets me to the next point. So that's this positive 12 you see right here. Now, that means my slope is negative 6 over positive 12. Now, if you have one negative sign in your slope, either on the top or the bottom, it doesn't matter where. If there is one negative sign, the entire slope is negative. Think about it. This slope was positive. Look at the direction of the line. This slope is negative. Look at the direction of the line. That drives which direction your line is going. Okay? Next, if your top number and your bottom number are both evenly divisible by the same value, then you need to reduce it. So we simplify our fractions. We don't leave them in this form. I would never put negative 6 over 12 into an equation, because that's not a simplified slope. Instead, what I would do is notice, 6 and 12 are both divisible by 6. What's 6 divided by 6? Well, negative 6 divided by 6 is a negative 1 on top. What's 12 divided by 6? Well, that's a positive 2 on the bottom. So what's my slope? It's negative 1/2. And again, all slopes are fractions. Some of those fractions can represent as whole numbers, like this one could. If your bottom number in your fraction is 1, then it can be represented as a whole number. Okay? Now, I just want to point out that because I could simplify this slope, I could have counted just down 1 and right 2 and ended up right back on my line. But what I was doing was using the 2 points I was given to count all the way. And notice that could have been a reduced slope right from the get-go. Okay, but I used the 2 points I was given to do that counting part. This is how we count our slope. Find the first thing left to right, and then either count up or down, and then right to get back to the line. And that will help you get your both number of paces that you've counted and your sign correct with your counting. Okay, so you can determine the slope of a line that way. Now, we've got this whole little like bird icon here indicating different directions of different slopes. So when you look at a linear function or a line in general, you should be able to determine positive, negative, horizontal, or vertical right from just looking at it. And these are the four ideas that we've got. You can determine the sign of the slope just from this looking, right? This direction of a line is a positive slope. As x increases, y increases. This direction of a line is a negative slope. As x increases, y decreases. This direction of a line is what we call a zero slope. Okay? As x increases, y stays the same. This type of a line is what we call an undefined slope. X doesn't change. So x isn't increasing or decreasing. X is staying the same. This is not a function. This is not a function. This is the only type of line that is not a function. The rest of these are linear functions. These are all linear functions. They do not have repeated x values. This, however, is a repeated x value into infinity. This is a vertical line. And this is why, by the way, the vertical line test, when we are testing to see if something on a graph is a function or not a function, this is why the vertical line test is a thing, because a vertical line is a repeated x value into infinity. So if this touches more than one x value on your graph, then that graph is not a function anymore. Okay, so that's why the vertical line test is a thing for graphing. Now I just want to go back to this one right here. This is a horizontal line. And again, this is a repeated y value. Y values, they can repeat in functions. We don't care about that. We care about whether or not x values repeat in a function. Okay, so these are functions. This is not a function. And by the way, we call this undefined because the x value is the bottom of the fraction and it is staying the same. It's a zero. We're going to see that when we start to apply the slope formula. But we know from lesson 4 of chapter 1, we cannot divide by 0. That makes our fraction undefined. That's why this is not a function. And that's why we call this just an undefined slope. Okay, because we cannot put a number to it. We can't divide by 0. We can't put an actual value to this slope. Okay? Now, we are going to use the slope formula. The point slope formula is m equals y2 minus y1 over x2 minus x1. You want to memorize this formula. Oh, did I say want to? I meant need to memorize this formula. You must memorize this formula. Okay? We are going to use this. You got to know that what your slope is, calculated wise, is the difference in your y's divided by the difference in your x's. And it's very specific about which x's and y's go first, isn't it? Okay, notice this is a point with the x value on the bottom and the y value on the bottom. This is a point with the x value on the bottom and the y value on the bottom. And we are taking the difference of those two things. We are subtracting. So what you do when you've been given 2 points and you want to figure out the slope, you don't have the picture in front of you. What you do is you take your 2 points and you label. The first point is an x1 and a y1. That's your x1 value. There's your y1 value. The second point is x2, y2. There's your x2 value. There's your y2 value. Now what you do is substitute those values in for y2, y1, x2, and x1 in your formula. Bring the signs with because those are part of the value. So y2 is negative 2 minus y1 is 4 divided by x2 is 8 minus x1 is negative 4. So notice I bring the signs with even though I'm doing that subtraction. And now it's just a simple calculation. On the top, negative 2 minus 4 is negative 6. On the bottom, 8 minus a minus. Minus a minus is really plus a positive. get a positive 12 on the bottom. And what does that reduce to? Well, negative 6 divided by 6 is negative 1, and 12 divided by 6 is positive 2. My slope of this line is negative 1/2. And I already figured that out because these are actually the exact same points on this line that was on the top, the front page of our notes, where I literally counted down 6 and right 12 to get my slope of negative 6 over 12. So what we're doing is showing you that connection between actually doing the calculation of those points in this formula versus physically counting on the graph. You're not going to be given both. You're going to be given one or the other. You've got to know how to figure out your slope either way. So you've got to know how to calculate your slope by counting. You've got to know how to calculate your slope by the formula. Let's keep going. Find the slope of the line passing through the points 4, 3, and negative 5, negative 2 using the slope formula. Well, there it is. I'm specifically told I need to use the slope formula. So I write it out. M equals y2 minus y1 over x2 minus x1. And I get, let's see, let's label our points, right? The first point I see is 4, 3, so x1, y1. Second point I see is negative 5, negative 2, so x2, y2. Got it. Now let's substitute in. Y2 is negative 2, minus y1 is 3. Okay, there's my top. X2 is negative 5, minus x1 is 4. Okay, there's my bottom. On the top, negative 2 minus 3 is negative 5. On the bottom, negative 5 minus 4 is negative 9. When you see a fraction that has a negative over a negative, you never leave a negative over a negative. Because what is a negative number divided by a negative number? A positive value. 5 and 9 can't reduce further, but you can't leave negative over negative. So my slope is 5/9. That is the slope of the line that connects those 2 points. Write out the slope formula. Okay, write it out as you're using it. Because the more you write it out, the better you will be at memorizing it. The more you write it, the more times you write out m equals y2 minus y1 over x2 minus x1, you will memorize it. Speaking of, what I'm going to have you do right now is pause this and try these 2 problems right here at the bottom. Okay, so pause this right here. Try these 2 problems at the bottom. You've paused it, right? You paused it? Here's your opportunity. Okay, give me 1 sec. I'm going to stop this so that you can pause this. That's what I wanted, was right here. And we will be right back with the answers. Okay, you ready? Here we go. There are the answers. So right here, I wrote out m equals y2 minus y1 over x2 minus x2, x1, x2 minus x1. I labeled my points. The first point I saw had an x1 and a y1. Second point I saw had an x2 and a y2. And then I substituted those values in to get negative 1 over negative 6, which of course reduces to a positive slope, positive 1/6. Over here, through the point negative 2, 1, which is right here, I had to now draw a line whose slope is 3/2, 3 over 2. So up 3, that's positive 3, right 2, up 3, right 2, up 3, right 2. Now, once I had gotten done fitting as many up 3 and right 2s as I could, I came back to the point and I counted down 3 and left 2, because down 3 is negative, left 2 is negative, and a negative over a negative gives me a positive slope. And see how they end up on the same line and forming the same positive slope? Anytime you graph a line, you use a straight edge. I have listed in chapter 3 so many different types of straight edges. You can use the side of an index card, the side of a piece of cardstock, the side of a ruler, the side of a notebook, like the front cover of a notebook like this. A nice solid straight edge. Use a straight edge to draw a line. I will not accept your homework assignments where you do not use a straight edge to draw your lines. There is always something that you can use as a straight edge to draw your straight lines. I'm giving you lots of options there. Okay, tonight's homework isn't going to involve drawing lines. Instead, it's going to be either counting your slope and then stating your final answer, m equals, or figuring your slope using the slope formula. So for each of these, you want to be writing out m equals y2 minus y1 divided by x2 minus x1. Make sure you're writing that out each and every time so that you are memorizing the slope formula. And then, of course, we've got two kind of applied slope questions down here, okay? And then we'll talk about slope for another day, all right? All right, guys, this was your Chapter 4, Lesson 1, Day 1 notes. Okay, I shall be seeing you for Lesson 1, Day 2. Enjoy!